Alright, hey guys, sorry I am not there, but I hope this video kind of explains everything a little bit for you. After this video, I'll go into your Google Classroom and show you exactly what you need to do. So just, stay tuned. Okay, so today we're discovering a new law. This law is called power to power. So first, what I would like for you guys to do is observe here how x to the fifth can be written as x times x times x times x times x, which we already know. But what about like xy to the fifth? Well, that can be written as xy times xy times xy times xy times xy, right? But what about also, let's think about like x to the second to the third. Well, that could be written out in expanded form as x squared times x squared times x squared, which would simplify to give us x to the, well, we have two x's here, two x's here, and two x's here, so that would be 6 x's. So I'm going to do the first one with you, and then I want you guys to pause the video and do the rest. All right. So m to the third to the second expanded would be m to the third times m to the third. When we condense it or simplify it again, that would be m to the sixth, because we have 3 m's here and 3 m's here. You guys pause the video and try the rest. All right. A to the second, 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 a to the 10th. X to the fourth, x to the fourth, x to the fourth, x to the 12th. P to the 6th, P to the 6th, P to the 12th. Now, what I want you to do is I want you to look and see if you can find a shortcut to go from there to there, there to there, there to there, there to there. What do you notice? I'm hoping you said that you noticed that you kept the base and multiplied your exponent. That's our new rule. It's called power to power. And it's when we keep the base and multiply exponents. Now don't worry, you're going to see a whole lot more practice of this in just a second. But that's our new rule that we are discovering. All right, let me go ahead and pull up our next activity, which is going to be the printout called Power to a Power Rule. So make sure you get that from the substitute teacher up front, and then we'll get going. So now everybody should have this paper in front of you. It's called Power to a Power Rule. You can see that 4 to the second to the fifth gives us 4 to second, 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 which gives us 4 to the 2, 4, 6, 8, 10. A shortcut would have been to do 4 to the 2 times 5. That gives us 4 to the 10th. Now this rule only works when you have a power raised to a power. It doesn't work for anything else, no other situation, just a power raised to a power. All right, let's practice. X to the third to the fifth. We will keep the base of x, and we will multiply our exponents. 3 times 5 is 15. So the answer here is x to the 15th. Slide over. Here we have mp to the 6th. Now, a lot of you guys are going to be like, oh, it's going to be 6mp, which it's not. But if you think about it, 6mp would be mp times mp times mp, and so on. So that would be 6 m's and 6 p's. The way to use the power to a power rule here is to remember that they are raised to an exponent of 1, which means you're going to do m to the 1 times 6 times p to the 1 times 6. That simplifies to give us m to the 6th, p to the 6th, or we don't need that multiplication between. All right, fill in your invisible exponents. 5 has an invisible 1, so we're going to do 5 to the 1 times 3. 1 times 3 is 3. And then z to the 7 times 3. which is 21. So 5 to the third, z to the 21st. If you want to simplify 5 to the third to 125, z to the 21st, you can. Either answer is perfect, acceptable, and that's good to go. All right, here we go. Fill in your invisible exponents, then multiply them. 1 times 6 is 6, so we have 2 to the 6th. Then 7 times 6 will give us, not that, p to the 7 times 6, which is p to the 42nd. If you want to simplify 2 to the 6th, you can, but you don't have to. 64p to the 42nd. And this is a repeat, by the way. All right, fill in our invisible exponents. So we have 1. So when we multiply our exponents here, this gets to be a little tricky because we're involving a negative when we're raising it to a power. What that does mean is that I have to keep that negative in parentheses. 1 times 3 is 3, but since the exponent of 3 wasn't on the original -3, we have to keep the -3 inside of parentheses. 3 times 5 is 15, so we have x to the 15th. If you want to simplify -3 to the third, you absolutely can, but you don't have to. It would be -27 x to the 15th. That one's a repeat. Slide down. Now we're getting into a little bit trickier of a zone where we have maybe 3 inside. Fill in your invisible exponents. That's always your first step. Now you're going to do power to a power. Keep the base of 5 and multiply your exponents. 1 times 3. That's 3. Keep the base of a, multiply your exponents. 4 times 3. That's 12. Keep the base of b, multiply your exponents. 6 times 3. That's 18. Again, you can simplify the 5 to the third, or you could not. It does not matter to me. So either answer is acceptable. Here again, don't get tricked by this beautiful little negative here. When you do 1 times 3 to do your power to a power, you have to keep your -6 in parentheses. So you get -6 to the third. Keep the base of m. 3 times 2 is 6. Keep the base of p. 3 times 4 is 12. Again, you can simplify the -6 to the third if you would like to, but you don't have to. -2 is 16, m to the 6, p to the 12th. Now what you're going to do is you're going to practice with pixel art before moving on to the combining like terms. So what I want you to do is I want you to pause the video and you're going to go do this pixel art. Let me show you. Google Classroom, other login, and period 1, classwork. Oh, of course, we're going to take forever to load. But that's okay. Stream maybe classwork won't take forever. Okay, here we go. If we open up Tuesday, you're going to see this number 1 power property of exponents. You're going to open it up and it looks like this. It's like one of those multiple choice things again. So for each one, you're going to select the correct answer. If it is correct, part of the picture will show up. If it is not, it won't. Please do not just click things until you get it right. Please try your best. This is how I'm going to know if you understand it. When you finish with this, come back to the video and we will finish the bottom half of this page. All right, hopefully now at this point you have finished number 1 power property of products, whatever that says, the mystery picture that has the multiple choice. Sorry, I can't talk today. So now what we're going to start doing is incorporating more than one rule. For this first one here, you can see that we have x to the 5th to the 3rd raised to the 2nd power, and then we have this piece. These two are being multiplied. So if we follow the order of operations, what has to happen first? Our exponents or our multiplication? Well, our exponents have to happen first, so we're going to do our product rule first. 2 times 5, we'll keep the base of x, and 2 times 5 is 10. We'll keep the base of y, and 2 times 3 is 6. Then we'll leave our multiplication symbol, And we'll do the same for the other side. X, negative 3 times 2 is negative 6. Y, 2 times 2 is 4. Now, normally after we apply our product rule, we're finished. Except now, I can now use a different rule. I meant our power rule, sorry. Now we can use our product rule where we keep the base and add our exponents. So here we'll have x to the 10th and x to the negative 6. We'll keep the base, and then 10 plus negative 6 gives us 4. Then we have y to the 6th times y to the 4th. We'll keep the base of y, and we will add 6 plus 4, which is 10. Then we want to check for negative exponents, which we don't have, so we are fully simplified, and that is our final answer. If we had a negative exponent, we would most definitely have to turn that positive. All right. Now here you can see the split. We have this piece with a power 2 power, and this piece with a power 2 power. So we have to handle our exponents first. First, we'll keep the base of x and do 5 times 3, which is 15. Then we'll keep the base of y and do 5 times 2, which is 10. Bring down our invisible multiplication symbol. We'll keep the base of x and do 7 times negative 3, which is negative 21. Keep the base of y and do 7 times 4, which is 14. From here, we have x to the 15th times x to the negative 21st. We're going to keep our base of x and add our exponents. So 15 plus negative 21 gives us negative 6. Hi, Lucy. Then we have y to the 10th times y to the 14th. We're going to keep the base of y and add our exponents. Now we want to check for negative exponents. Well, we most definitely do have one right here, which means we need to handle it. Right now it's currently in the top, so it needs to go to the bottom. So we have x to the 6th on the bottom, and y to the 24th is positive, so it stays on top. That is our final answer. Kind of getting the hang of it? If you are and you feel confident, you can try some more ahead of me. That's fine, just make sure you check your answers here with me. Alright, for our next one, we've got only one power to a power here. So we need to do that first, and then we'll copy this down. We'll do times. Then we have the base of negative 2, which is to the first. 1 times 3 is 3. The base of r to the 3 times 3, which is 9. The base of s to the 3 times negative 2, which is negative 6. Now, we need to figure out what negative 6 times negative 2 to the 3rd is. Negative 6 times negative 2 to the 3rd gives us an answer of 48. So we have 48. Keep the base of r, do negative 5 plus 9 gives us 4. Keep the base of s, negative 2 plus negative 6 gives us negative 8. Check for negative exponents, and we most definitely have one right here. So that means it's currently on top, which means it has to go to the bottom. 48 stays on the top because it's got invisible 1, which is positive, and r to the 4th stays on the top because it's positive exponent. Alright, here we've got 1 power 2 power on this side, so we're going to copy down the right hand side. I'm going to go ahead and put in my invisible exponent so I don't forget. Now let's do power 2 power. So we have 3 to the 1st to the 4th, which is 3 to the 1 times 4, which is 4. Keep p, which has invisible 1. 1 times 4 is 4. Q has invisible 1. 4 times 1 is 4. Now we're going to write in our invisible 1 here. So we know we have 3 to the 4th times 1, which is 3 to the 4th. P to the 4th times p to the 6th gives us p to the 10th. Q to the 4th times q to the 1st gives us q to the 5th. Check for negative exponents, which we don't have any of, so this is our most simplified answer. Alright, I think there's the second last one, yeah. Here we have 2 power to a powers again, so we're going to do one at a time. Write in our invisible exponents so we don't forget. We have negative 3 to the 1 times 3, which is 3. Base x to the third to the third. 3 times 3 is 9. Base y to the 2 to the third is 2 times 3, which is 6. Bring down our invisible multiplication. Then we have 2 to the first to the second. 2 times 1 is 2. Keep the x base. 2 times 4 is 8. Keep the y base. 2 times 2 is 4. Now we need to figure out negative 3 to the third, which you can just punch into your calculator. Negative 3 to the third times 2 to the second gives us negative 108. Then we have x to the 9th times x to the 8th gives us x to the 17th. Y to the 6th times y to the 4th gives us y to the 10th. Check for negative exponents, which we don't have any of, so we are in our most simplified answer. Last but not least, we have a little bit of a different situation over here where we have this coefficient 5 out front. Don't let that trick you at all. It doesn't really change anything about what we're doing. We just need to multiply this by our final answer. So we're going to have 5 times invisible exponent 2 to the third. Keep the base of x. 3 times 4 is 12. Keep the base of y. 3 times 7 is 21. Bring down our invisible times. Then we have x to the third to the second. 2 times 3 is x to the 6th. Keep the base of y. 2 times 5 is 10. Now we need to simplify. We have an invisible 1 here, so we're doing 5 times 2 to the third times 1. So 5 times 2 to the third times 1 gives us 40. Then we have x to the 12th times x to the 6th, which is x to the 18th. And y to the 21st times y to the 10th, which is y to the 31st. Check for negative exponents, which we don't have any of, so here we go. Alright, now let me show you your next mission. In Google Classroom, you're going to see number 2, power to a power mystery puzzle. You're going to open this up, and this one is indeed like a pixel art activity, so you're going to type in your answer to the boxes. So you'll see the example here has 1x to the 18th, so that means in this blue box right here, which I can't point to, but that one, you're going to put your coefficient in the first blue box and your exponent in the second one. Coefficient in the first blue box and your exponent in the second one. Here you're going to do coefficient in the first blue box, x exponent in the second blue box, and y exponent in the third. If you have questions, please read the directions or ask the sub to help you. Alright guys, good luck. Thank you so much.